Example number 5, and remember that homework problem we did, number 3, yesterday on the board? Hey, AP, my AP
The one
test
you did
takers.
wrong?
Well, it's not that I did it wrong, it's a pattern. So I figured out a way to do it a little easier. But the pattern is that when we do the integration by parts, well, let me write this down and I'll explain it. When we do the integration by parts, sometimes, based on the function itself, it will never ever go away. So if I do the integration by parts, e to the x, if I take the derivative of e to the x, it's just e to the x. If I take the antiderivative of e to the x, it's e to the x. So if I do integration by parts on this, what's going to happen is I'm going to get a uv minus v du, and when I go to do this, somewhere there's going to be an e to the x. And then to solve this, I'm going to need to do integration by parts on this, right? And then I will still have an e to the x term, which means I would need to do integration by parts again. And so when we do that, there's a couple of things that could take place. It could go on forever. It could have a pattern that emerges, or sometimes it'll just drop off. In this particular case, it will just drop off. And since we're going to repeat the pattern over and over and over again, we're basically going to take derivatives of one of the function, and then we're also going to integrate the other function. Alright? Because that's the way integration by parts works. So rather than write it all out, that I can't talk, I'm sorry. I'm slurring my words. I'm just trying to live.
Just trying to live.
I can't breathe and talk at the same time. Alright, so tabular integration is integration by parts, but we're just going to pick one function and take the derivative of it, and then take the other function and take the integral of it. And we're doing the integration by parts, we're just writing it in tabular form. So if I start with x squared, okay? And then at some point in time, by doing the integration by parts, I would need to take the derivative of this, it would be 2x. Then if I take the derivative a second time, it would be 2. And then if I take the derivative a third or fourth time, the fourth term down, third derivative, I end up with 0. If that 0 becomes a part of that, in other words, at some point in time, we've got this uv minus the integral we're going to end up with a 0 here. Does that make sense? And so then that term goes away and then we're done. We can't go any further. So in this particular case, it works out great. Now, if I do that, then the odds are, if I keep everything the same, then I could take the integral of e to the x. So if I take the integral of e to the x, whoops, I'm going to start with e to the x, then the integral of e to the x is e to the x, and then the integral of e to the x is e to the x, and then the integral of e to the x is e to the x. So my first uv would be this. Then my next uv would be this. Then my next uv would be this. Okay?
Thank you.
Now the first uv will always be positive, but because the integration by parts has this this little negative sign right here, the next time it'll be negative, and then the time after that it'll be the negative of a negative, which will be positive. So we have this pattern that emerges, negative, positive, and it alternates. So the first one's always positive, the next one's negative, and all that stuff. So now, what am I saying? I can, by doing integration by parts, deriving one function, integrating the other function, I can take and find the antiderivative of this simply by following this pattern. So the next thing that I would do is the terms of the integral, all right, are going to be this. That's the first term. This is going to be my second term. Okay? This is going to be my third term. So I can find the integral of this is simply going to be x squared e to the x. I've got this minus sign, so it's going to be minus 2x e to the x. Whoops. E to the x. And then lastly, it'd be plus 2e, and then we got to tack on the plus c at the end. Okay? Oh, it's e to the x, I'm sorry. E to the x, I forgot the x part. Okay, are there any questions on that? Now, when can we use tabular integration? If you see e to the x or sine or cosine.